We have a exam coming up Thursday. Truth. So it is truth. Well, I mean, you never really know. There's always some probability. There's a non-zero probability. So, right. But anyways, there's a practice test. I don't know if you guys had a chance to look at it. It was just like last time, it has some practice problems for you to take a look at, kind of similar to what you should expect in the exam. There was last quarter I had to update my solutions to number 12, so there's part of the solutions are separate, basically, because if you look at that one, it's not complete. Or I can't remember if it's not complete or I made an error, but anyways. So the solutions are there, so I would check those out. Give them a try. My recommendation is try them without the solutions first, so then when you can kind of get an idea of what you need a little more work on. And then, again, I have the extra practice on here. This is the probability you want to hand it out. That some of you guys hand it back. I need to post the solutions for that. I'll get it up by tomorrow, though. We will finish Module 5 today, and then we will have a review day tomorrow. And there is your last quiz for this discrete stuff is tomorrow, but we'll finish all that stuff today. Okay? Any questions about the test or coverage? It's pretty straightforward. Regression, probability, and then the stuff we did yesterday and today. That's what we're working with. And I'll try not to make the exam so probability heavy that it's just like the worst thing in the world. But it'll be on there. So give those practice problems a try. All right. Any other questions before we finish off Module 5? All right. Okay, so yesterday we were talking about discrete random variables, and the idea was that that's not the button I meant to push. The idea was, now that we kind of understand probability, we want to start applying it to scenarios and sampling. And because when you start sampling, things start to become variable and unpredictable. So we're focusing just on discrete random variables before this exam. And so that's a random variable is something whose outcomes are determined by chance. Discrete random variables are the same thing. They're just discrete. We kind of know what discrete data is. And so I walked you through a little example. But the moral of the story is that for discrete random variables, you can construct what we call their probability distribution. So probability distribution, it shows all the possible outcomes in one column, and then it shows how likely they are to occur in the other column. All right, that's a probability distribution. Those are the two things a probability distribution tells you. And you can see here that if you were to randomly pick a student from that class, some values are more likely, some values are less likely, right? When we talk about distributions of data, though, the two of the things we consider about the distribution of data is their mean and their measures of center and spread. So I showed you yesterday that you can calculate means and standard deviations. I kind of walked you through an example, but the point is that the mean you can do with this formula, the sum of each outcome times its probability, and then the standard deviation you can do with this formula. And we did that on this example yesterday. I don't have my annotated notes right here on me right now. But if you weren't here yesterday and you want to see that problem, it's on the video from yesterday. You can just go watch the end of my lecture yesterday, and you can see me work that one out. The standard deviation is not... we calculate the standard deviation just because it's good to have a measure of variability in your data set, but it's not as applicable as the mean. The mean has a very straightforward application for discrete random variables, and that's what I want to talk about today. So sometimes the mean is called the expected value. So and the reason that we call it the expected value, it's because the mean is what you expect to happen on average in the long run. It's kind of like probabilities, right? Probabilities are proportions that you will realize in the long run, and the mean is also something that you will see on average in the long run. If I just pick one person from that class I showed you yesterday, then they're going to have a number of siblings. It's not going to be the mean, right? Because the mean was 1.96, and nobody has 1.96 siblings. So, but if I sampled enough people over time, on average, I would see 1.96 siblings per student if I did it over and over and over on average. That's what I expect to see. So that's why it's sometimes called the expected value. And the expected value is particularly applicable in things where you're trying to predict or trying to plan for things that are going to happen in the future. So the example I'll give you first is like a gambling example, but it's also very applicable like in insurance when you're trying to calculate, okay, well, how much should we charge for premiums in an insurance plan or something like that. Okay, so I'll show you both examples of that. So, all right. So casino games have to use expected values because they have to make sure that they don't go broke, right? They have to make sure that they stay in business. So roulette, here's an example of a roulette game. This one was on the quiz, or it is on the quiz. So the way that you play roulette is there's 38 slots, and they have 2 green, so then the other 36 are red and black, and they alternate. So that means there's 2 green, 18 red, 18 black. And those are numbered, and you can make all sorts of bets on a roulette wheel. So you can bet on single numbers, you can bet on colors, you can bet on like dozens where you bet on 12 numbers at a time. I don't know, there's lots of bets. Maybe someone here plays roulette more than me and knows all the roulette bets, but there's tons of them. And the thing is it's kind of like that game I was talking about, like that theoretical game where you could roll dice, or we could roll dice and I give you extra credit or take away points. Every different bet has a different payout. And so the more likely you are to win, typically, the less payout they're going to give you, and the less likely you are to win, the more payout they'll give you. You know, whereas you get all the way up to like Powerball, and the payout's like 1 to 12 million or something, because it's like you're never going to win or something. So anyways, so here's the setup. So you can bet on a color, for example. So you can bet on red, and if you bet on red, that's a 1-to-1 bet, because a red bet's pretty likely to win. You know, you have a decent chance of winning a red bet, so they're only going to pay you 1-to-1. That is, if you bet $1, if you win, you get $1 back. If you lose your $1. Okay, that's called a 1-to-1 bet. It's called, so that would be like even odds. Anyways. So what we can do is you can actually calculate the expected value of a $5 bet. And when I say the expected value, that's just another way of saying the average or the mean of a $5 bet. We're going to use the formula from before. Okay, I think I might have part of this filled in. Okay, so if you're going to make a $5 bet, okay, so if I'm trying to figure out the $5 bet, if I'm going to put $5 down on the table and bet on red, there's only 2 things that can happen to me, right? And what are those 2 things? I'm either going to win or I'm going to lose. And in terms of my money, what's going to happen? I'm going to lose $5, or I'm going to do what? I'm going to go up $5 because it's a 1-to-1 payout. Okay. If it was a different payout, there would be it wouldn't be 1-to-1. All right. So what we can do is we can set up a probability distribution with only 2 outcomes. I'm either going to win or I'm going to lose. I think this one I might have already put that in there, right? So let me see. Oh, I have it right. So there's an outcome. We could go what? Up $5, or we could go down $5. That's really our only 2 possibilities. All right. Now, we could also figure out what our probability of doing that is. So what's the probability that you win $5 if you think about the way the roulette wheel was set up, if you're paying attention back here, because that's the setup, right? 18 red, 18 black, 2 green. So what's the probability of winning a bet on red?
18 out of 38.
Yeah, so there's an 18 out of 38 chance that you win. So notice those 2 green make a difference because it keeps your probability of winning a red bet under 50%. And that's why they'll give you even odds or even payouts. So it's 18 out of 38, which means what's your probability of losing?
18 out of 38.
It's not 18, though. It's the other. Yeah, see, that's the thing. That's how they keep the edge on a colored red or a black bet. Okay, so you're going up $5 with an 18 out of 38 chance. You're going down $5 with a 20 out of 38 chance. This is a probability distribution, right? This is a probability distribution It's the probability distribution of your winnings or losings on a $5 bet. Right? So it shows you all the possibilities and how likely they are to occur. This one's very simple because you're either going to win or lose. Now, could we calculate the mean or the expected value? Sure, right? It's just the mean, we know from yesterday, is just the sum of each outcome times its probability. Okay, well, in this case, that's pretty straightforward because there's only two outcomes, right? You're either going to go up $5, so it's either up $5 times its probability, or you're going to go down $5 times its probability. And so we're actually going to take that table and turn and calculate the average value of a bet. Now, if you do that, so calculate that, so you could turn that into a decimal if you want and then multiply, or you can just plug it all in your calculator once, it'll work. What do you come up with if you calculate 5 times 18 out of 38? And then this actually, what is it? This just ends up becoming subtraction, basically, right? Because that number is going to be negative. So you have some positive expectation from winnings, but you also have negative expectation from losings. And when they balance each other out, what do you get?
Negative 0.26.
Yeah, it's like negative 0.2.
Yeah.
What does it come out to be? Is there more decimals?
63.
263 ... Right? And if we're rounding this, we're talking about money, so it makes sense to round to the nearest cent. And so I think that's what you're thinking probably. So there'd be negative 26 cents. So what is that telling you? So if you're gambling on this game, what is that number telling you right there? It's, yes. On average, in the long run, if you play this game over and over and over and over and over, every time you bet $5, you should expect to do what? You should expect to lose 26 cents. Now, can you actually lose 26 cents on a single bet? No, you can't, right? You're either going up 5 or down 5. This is a long run average. So now what does that mean for the casino?
They're making 26 cents.
Right, so they can count on it basically. They can count on every time someone places $5 and they bet on red, they can put 26 cents in the bank. Boom, right? And another $5, that's 26 cents in the bank. And that's not how it really looks. Their payouts actually, they're paying out 5 and losing 5 and gaining 5 and losing 5, gaining 5. That's what it really looks like. But in the long run, that's what they can expect. Sorry, go ahead.
Will it always be negative no matter what amount of money you put in?
It will on casino games. Yes. Yeah, at least for the player's point of view. Because the casino's point of view, this is flipped. From the casino's point of view, they actually, this is a gain for them, and this is a loss for them. And so they would flip it, so they would have a positive expected value. But from the player's point of view, what this is telling you is that, so for every $5 that you bet on red, expect to lose 26 cents on average. So that's the idea. So if you play this game 100 times, betting $5 each, at the end of those 100 bets, you would expect to be down 26 bucks from where you walked into the casino. All right. So, does that make sense? Okay. And in this case, the thing is like the standard there's a standard deviation to this bet, and that would be interesting for single bets, but the casino doesn't care about single bets, right? They don't care about one single person winning because they know that in the long run they're coming out ahead on average. And that's how they set payouts. And that's why I was talking about the dice game that I was showing you. I'm trying to remember the rules. We could do it. It won't take very long. But I was showing you the dice game, and it was like, what was it? I told you that you could bet on I told you you could bet on rolling a 7, right? Wasn't that it? Right, out of 2 dice. And so then the probability that you win was, wasn't it like, ended up being like 1 out of 6 or something?
Yeah.
It ended up being 1 out of 6, which was 0.1667 if you round. Okay, so my original one is I offered you a payout, and I said, like, okay, you can gamble a point. What was it? What was the original offer? I said I'd either give you 10 points back, or you would lose 5 or something like that. I can't remember. Wasn't that what it was? It was something like that. Like, that was your option. So I'd either give you 10 points back on your exam, or I'd take away 5, and you had to pick, right? So you could actually figure it out, and you could say, okay, so there's only 2 options here. I'm either going to lose 5 points, or I'm going to gain 10. And so on my, if you look at the payout there, then it's like, okay, well, I'm going to win with a 0.1667 chance, but I'm going to lose with the opposite of that, right? Which would be 0.88333. Okay, so then you could actually figure out the expected value of my game to decide if you want to play my game. Right? So you could multiply, so -5 with an 83% chance, plus 10 with a 16% chance, and then if you do that, what do you get if you calculate that out? I don't know the answer. It's probably not good. I don't think the payout's in your favor if I modified it that way.
-2.5.
-2.5 if you round. Something like -2.5. So is that a good game to play? That's a bad game to play because you should expect to lose 2.5 points on average every time you play. And so you don't want to play that game. But if I changed it and I said, like, let's say I offer to give you plus 10 or just take away 1, right? What if I change the odds on you? Or I change the payout on you? So then it changes. So there's less risk to you, right? And then, so we would change our payouts here. And then you'd have -1 times 0.833 plus 10 times 0.1667. And what does that come out to be? 8333. It should be a 3 there. 8333. Oh, you're telling me the answer.
That's the answer.
Oh, what was the answer?
0.8337.
Yeah, we'll just say 0.8 since we rounded the other one. See, then that would actually turn the game into a positive expectation, and then you should play that game. Because even though you're going to lose some points sometime, in the long run, you're going to make more points. So in the first game, you're going to run out of points eventually. You're going to get a 0. And in the second game, you're going to infinitely accumulate points in the long run. Right, yeah. So the expected value tells you how good of a bet you can get on a given play on the casino floor. And you can look them up. Like, you can look them up online. You can look up expected values of bets. And some are better than others. But none of them are good. They're all negative. Right. Now the thing is, though, is that the thing about random variables is, in one play, you actually have a pretty decent chance of beating the house, right? So in one play, you have a very decent chance of beating the house, but in the long run, you're never going to beat the house. So if you're going to gamble, what's the best strategy? One gamble, yeah. So the best strategy, if you want to try to beat the house, which you probably won't, but you could, your best strategy to beat the house is however much money you have, find the best expected value, find the best odds in the house, bet it all on one bet, and then if you win, you should quit, right? And if you lose, you have to quit anyways because you have no more money. But if you win, you should still quit because as soon as you keep playing, you're playing into their expected value, right? So the longer you play, the more you're going to lose. The less you play, the more likely you are to come out ahead. So if you want, or you just don't gamble because the odds are still against you on one bet. But you have they're way more likely to come away on top on one bet. Okay, make sense? Okay, this is also how insurance policies work. So here's an example. This one's sort of a simple example. Obviously, insurance calculations are much more complicated than this because there's a lot of mitigating factors that control your probability of costing an insurance company money. But here's an example. Okay, so let's say you have like a computer company like Apple. They offer an insurance policy for their MacBooks. Let's say it's $200. Okay, and for $200, you get the insurance policy, covers the laptop for 2 years. If anything happens to the computer, you just send it in, and they give you a replacement laptop. Okay, they send you a new one, or they fix yours, or whatever. Okay, so what they know is they know from experience that the probability of their laptops failing, because they've been selling these things for a long time, and they do tests for failure rates. They know that in the first 2 years, there's about a 5% chance, that probability, that they're going to have complete failures in the laptops, and they're going to have to replace them. And if they have to replace them, they also know, because they've been doing this for a while, it's going to cost them $1,200. Say, okay? So the question is, if someone comes and buys this insurance policy from them, what's the expected value or the profit for the computer company? Does that make sense? So they're going to sell you a policy. Hopefully you're never going to collect on it, and they just get your $200. But there is some probability you're going to collect on it, and you're going to cost them money. So the question is, well, how much money should they actually expect to make in the long run on average? Yeah? So you can treat this like the other one. You can create a probability distribution, right? So there's only two things that can happen, again, right? So what's one thing that could happen for the computer company? If your computer never breaks down and I'm the insurance company, that's good for me because I'm going to make money on you, right? And how much money am I going to make? I'm going to make $200 on that person. Okay? All right, great. Now, how likely is that to occur? Pretty likely, right? Because this right here, this event right here is that the computer doesn't break down, right? There's no failure. And they know, historically, the failure rate, so actually the probability that they collect is actually the complement of that, right? So they'll collect $200, 0.94, yeah, like 94% of the time, they just collect the money, boom. Don't have to worry about it. Now, occasionally what happens, though, is what? They turn around and they have to pay money to replace an item. Okay? Well, so then how much does that cost them? $1,200. Yeah, there's two ways to look at it. Some people would say maybe if you think about what would a loss be, they do lose negative. They would go negative $1,200. Although really, what happened? Yeah, they already collected your premium, like on these protection plans, right? So they lose the cost, but they did recuperate some of that cost. So really, they only lose what? Yeah, they're really only losing like $1,000 because they collected. So they'd lose $1,000. Sometimes they make $200. Sometimes they lose $1,000, and then that happens what with 0.0568, right? Okay, so then we can calculate the expected value, and we say, okay, so they're either going to get $200 with a high probability, or they're going to lose $1,000 with a lower probability, right? And so this would be the calculation we can make. And then if you simplify that, what's it come out to be?
It's 131.84.
131.84. Okay, so there you go. So then, what does that number mean?
On average, that's how much money they're going to make.
Yeah, so they can tell that for every policy they sell, so for every policy sold, they should expect to make $131.84 on average. Right? So then, yeah, go ahead.
Why is it 1,000 instead of 1,200?
Well, it's assuming that that they already collected your $200 premium. Yeah, so it's like if you pay that cost up front, then they've already got that money from you, so they don't actually lose the full $1,200. Yeah. Okay. So even though it's a $200 policy, they're not actually, they can't count on getting $200 for every policy they sell. they need to count on only getting 130 of those dollars, because the rest of those dollars are going to be doled out when they have to pay out to other people. So then for their own projections, their own budgeting purposes, that's what they can expect, and then you just have to decide if that's an acceptable dollar amount, right? So if that covers overhead and all the other junk they have to pay for, then they leave it. Or the other option is they could raise their premium and get higher premiums. Or if they think that they can get away with less, they could lower their premiums and take less expected value in exchange for maybe being able to sell more policies. So they'd also do maybe like a cost-benefit analysis, to see if they could go lower. But, yeah? Does that make sense? Okay. I think that's it. I think that's all I got for these. So Module 5 is pretty short. Mostly it's just about kind of introducing discrete probabilities. They have probability distributions, and then understanding that expected values and the means are very applicable, because those are the kind of calculations that all sorts of industries use to make projections about the future. So, all right, that's all I got, I think, for Module 5. Okay, so tonight, make sure that you are checking out the practice tests and any of these maybe extra practices. Come tomorrow with any questions or things you want to see, and then we'll go from there.
Will you be in your office tomorrow?
Yes.